All right, so this day is a lot easier, I think, if you know kind of like how to handle it. But so yeah, basically you're given these grids and you want to find out how where they're basically flipped either horizontally or vertically. And so just right away, let's go ahead and parse the inputs. So I'll go ahead and create grids is equal to parse raw for raw and input dot split line. Or instead of split lines, let's split it on two new lines because you can see in the inputs here they're split like that. So now let's go ahead and create this parse function. So def parse and it takes in some raw string, and we're gonna go ahead and create a max x and a max y variable, and these will basically be like the maximum indexes we get. And so what we could do is we could do it's a little bit inefficient, but max y is equal to the length of raw dot split lines minus 1 because I want to get the highest index I could be at, and then max, and then I'll just get rid of this here. Max x is equal to the length of raw dot split lines and the first line minus 1. All right, and so now with these, let's go ahead and create a grid, which is going to be a set because we're basically only storing true, or like we're only storing the points where it's equal to this little smudge, I guess, or rock. So here, now with our grid, let's go ahead for y, l, and enumerate raw dot split lines for x value and enumerate on L. And here we'll do if v is equal to this symbol, grid.add, and we'll use our complex points again, which I already kind of wrote at the top, this. And we'll return our grid, our max x, and our max y. All right, cool. So now with this, we have our parse function done. If we want, we can go ahead and print this. And here, yeah, this looks about right. We're getting like a list of some kind of maps. And so these are points taking complex numbers. All right, so now let's go ahead and kind of start writing the code for solving it. So we'll do def solve grid max x, max y. And then now, so inside of here, we're basically just gonna see if it matches on the x. If it does, we'll return that value. If it matches on the y, we'll return that value multiplied by 100. Because we're all summing these together, that's all we really need. So we'll do for x in range max x. We'll test basically every x coordinate. And we'll go ahead and see if it is horizontal flip. And we'll define these functions in a second. Max x, x, and then return x plus 1. And the reason we're doing x plus 1 is because if you look here, we're indexing starting at 1, but in our code we're indexing starting at 0, so there's going to be that. But we'll have this, and then we'll go ahead and we'll basically do this again for y. And what we just do is vertical flip. And of course, we'll define these in a second, so don't worry if you don't have these defined yet. All right, so here, now we have this. And then also, finally, this should be multiplied by 100 because that's just what the question wants. All right, so let's go ahead and write these functions now. So def is horizontal flip. And so what this should do is basically just tell me if I flip my code across like the x-axis, like I flip it kind of across a vertical line, but like this. Like I kind of flip this part horizontally onto the other side, see if it works for this certain flip at an x. So if I say x is like 4, it should be flipping across 4 and 5. Index is 4 and 5. So now in our code, what we're going to do is for p in grid, for each point, we're going to basically do a little bit of math here. So we're going to create a new point. And so it's going to have an x and y. The y value is going to be the same. Or sorry. Yeah, so the y value is going to be the same. So we use the p.imag to get the imaginary component. And for the x value, what we're going to do is we're going to use this formula. And the way I got this formula was from a little bit of trial and error. But basically what I did is I kind of printed out like the code, printed out my indexes, and then sat down for a little bit and tried to kind of toy with the numbers to see what works. And so essentially what we're saying is currently whatever x value is plus, this should just be a plus here. All right, so what this is saying is like if we have a boundary like this, and let's say we're trying to flip this point, I want to find how far away it is from the center line, and then add that difference to the center line to get it on the other side. And then there's a little bit of like off by 1 errors because this is like a too wide thing. But yeah, if you just toy around with this and like see some examples, you'll see this makes sense. But yeah, from this, now what we're going to do is first we're going to make sure that this value is inside of our grid. because if it's outside of the grid, then it's fine. So we'll say if it is between, and we get our x, if it is between this x and UP, so the new point is not in the grid. So if it's within the range of the grid, but it's also not a point in the grid, then we will just go ahead and return false. And then otherwise, if we basically get through every single point in the grid and it has its flip point or it's out of the grid, then we should return true if it didn't return false earlier. So now let's go ahead and basically copy this over, and we'll do this same thing for y. So is vert flip, and then we'll paste this to a y, replace this to a y. Here, replace this to y. I think that's all of those, and then real should be changed with imaginary. All right, so I believe now this should be good. Let's just quickly make sure. Let's go through and look here. Oh, and this should be flipped because this is now the y value. All right, so what this is doing is basically the same thing as the other code. Yeah. And all right, cool. Let's go ahead and just see what happens when we run on our test case. Oh, this is not supposed to be a for. That is my bad. This is an if. And then finally, let's go ahead and actually call our code. So what we'll do is we'll sum up all of these values. So if I solve, and our g is a tuple, so we'll unpack it for g in grids. So I'm basically taking this tuple and just passing it out into all of these arguments here. Because you can see I'm returning basically 3 arguments like this. So if I go ahead and run this on the test, let's see what we get. 405. If I look here on the test, 405, that is correct. If I go ahead and submit my code, you can see part 1 is right. All right, so for part 2, basically what they're saying is 1 pixel is off. And so if you need to find where that smudge is and then use that new reflection line. So for example, here, this would have been the exact same if we got rid of this pixel here. And so that's virtually the same as if I added this pixel here, by the way. And so what we're going to do is basically we're going to modify, first of all this code to have a part 2. So let's go ahead and first copy all this over because we're only going to need that. And then we're going to pass in a part 2 flag. So we'll just do true for now. And then here we'll do in solve part 2 is equal to false by default. And then here we'll also pass whatever this is into these functions. And so in here, we'll go ahead and add this part 2. Part 2. So the way we're going to do this is we're going to basically have a flag. So the flag is going to be false. Wow. False. And this is basically saying the flag will be true when we have exactly 1 error. So now what we're going to do is here, when we get an error, so this code is basically whenever we get something that doesn't match up, like non-the-mirror. If it's not part 2, then we'll just go ahead and return false. But if it is part 2, so if this OR case is hit, then we want to, so either if it's not part 2 or it is part 2 and the flag is true. If the flag is already true, that means we already had gotten an error, and then we'll return false. Otherwise, we'll set flags equal to true here. So now, and also now that I think about this, we should just be able to get rid of this because, so either part 2 is false or part 2 is inherently true and flag has to be true for us to kind of return early. So let's go ahead and do that. So now we'll set our flag to true in this code, meaning basically, hey, this flag saying you've already seen an error. If it's not part 2, we return like normal. Or if you've already seen an error and you see another error, then that means it's like this isn't the reflection because there's more than 1 error. All right, so now with all of this, let's go ahead and finally return down here. Because we can't just leave it at this because we should only return if not part 2. So if it's not part 2, like it's part 1, return true automatically. Or return if flag is true. Because we should only return if we have exactly 1 error. So this is what we're going to change here. And so now let's go ahead and make these changes down here also. I think I can just copy all of these lines. That's nice. All right. So let's go ahead and now see what we get if I run this test. 400, which is the answer. 400 down here. If I go ahead and submit it. Oh, that's day 12. Here. Boom, we get the right answer.